Hi, I'm Nageshwara. Today I'm going to discuss about a small topic of trigonometry. Let us start our topic with some real life examples. We can see electric poles everywhere. So basically electric poles are erected using a metal wire, and electric pole and metal wire and the ground can form a triangle. But if the length of the wire is decreased, what will be the shape of a triangle? Can you guess? And one more example. Suppose a painter is whitewashing the wall. He wants to reach the higher position. And what will be the person do? Okay. And what will be the angle made by a ladder with the ground? These kind of problems geometrically showing the applications part of trigonometry and applications part of triangles. And we can measure lengths and the heights and the slopes using the applications of triangles. These kind of problems are as a part of trigonometry, which is a branch of mathematics. A trigonometry, actually the word is derived from two Greek letters, two Greek words. A trigonon, which is triangle, metron, which means measures. Trigonometry is nothing but measuring angles. It's all about measuring angles. Basically, we are going to use just right angle triangles because most of the things what you can see around us, this seems like a right angle triangles. Okay, right. Let us start our topic deeply. Suppose the painter is whitewashing this wall. He wants to reach the higher positions. What does the person do? He will increase the angle here, right? If he increase the angle, what will happen, right? The height increases. Once you increase the angle, the height increases, and the distance between the foot of the ladder and foot of the wall decreases. And what happens when the angle decreases? When the angle decreases, the distance, I mean the height of a wall decreases, and the distance between the foot and foot of the wall increases. So surely you can find that there is a relation between the angles and sides. Yes, definitely. As the angle changes respectively, they can find the change in the sides. So those are said to be ratios, right? We will discuss more about that. So before that, first let me take a one right triangle. You know how to name the sides: BC, AB, and AC. This is all we know how to name commonly, but we are going to discuss more about the sides. So let us rename the sides. How to rename? Let me take this triangle. I mean that it is right angle at B, and the side which is opposite to the right angle, I mean the longest side. The longest side can be, you can take it as a hypotenuse, the longest side. And let me take one acute angle, that is CAB. Let the angle be suppose A, suppose let it be taken as A. And now observe the side BC with respect to A. We can say that side BC is opposite to the A, right? That's why we can call it BC as a opposite side of angle A. And what about other side? The other side can be taken as a adjacent side of angle A, right? Clear? So these are the new names of the sides of a right angle at triangles. Right. Now let us move to the ratios of right angle triangles. The first ratio is the sine ratio, right? How do you get the sine ratio? The sine ratio we can get that opposite side by hypotenuse. Opposite side of angle A by hypotenuse. It is a fixed for it is fixed for all the right triangles because all the right triangles are similar, right? So the constant, what is the sine ratio? The ratio between opposite side of angle A and hypotenuse is always constant, right? This is sine ratio. Now look at the cos ratio. How do you get the cos ratio? Adjacent side by hypotenuse. adjacent side by hypotenuse, right? Now look at the tan ratio. Tangent of angle A, it is nothing but tan A, opposite side of angle A by adjacent side. Okay, opposite by adjacent. Now look, actually basically there are three ratios, and again there are three more ratios which are simply multiplicative inverse of the, there are these three ratios, right? Now look at the tan cot ratios, or cot ratio, actually the inverse of tan ratio, and it will be like this: adjacent side of angle A by opposite side of angle A. And what is sec ratio? It is inverse of cos A, that cosine ratio, right? Sec A, how do you get the sec A? Hypotenuse by adjacent side, hypotenuse by adjacent side, okay? And finally the inverse of sine ratio, cosecant A, the cosecant A is hypotenuse by opposite side of angle A, right? Hypotenuse, right? Opposite sides. So these are all the ratios of an angles. Using these ratios, we can find the unknown sides. Okay. I hope you understand. Thank you very much.